Welcome back again. So we have this question on differentiation. We are given the function y is equals to e raised to x sin x, and we are told to show that the second derivative of y minus 2 times the first derivative of y plus 2y is equals to 0. Now we know that when we are given y is equals to e raised to sin x, this is a product of two functions, e raised to x times sin x. Now what happens is that we are going to apply the product rule to solve this question, and the product rule states that given a function in terms of u times v, the derivative dy dx is equals to u dv dx plus v du dx. Now because this one contains two functions, it means that when you hold one part, we differentiate the other one and add the differential of the other part also. So we hold u, differentiate v, it gives us the first part plus the change with respect to u only when v is constant. So we go back to our function. We are going to call the first part u and call the second part v. So to get the first derivative, dy dx, it will be equals to u dv dx. Now u we are going to replace with ex times the derivative of v, which is sin x. So I can write it this way: u is equals to ex and v is equals to sin x. Now du dx is the same as ex, and du dv no d dv dx is the same as cos x. So we are now going to replace each part inside here. dv dx will be cos x plus v, which is sin x, times e raised to x. Opening up the bracket, we'll have ex cos x plus ex sin x. So this will be the first derivative of y. So let me put double line there to indicate that that will be the part that I also need. Now we are supposed to get the second derivative for this part, and for us to get the second derivative, we are going to repeat the same process, as these functions are products. Ex function, cos x function, ex function, sin x function. So what happens? We apply the same formula. We call this part u, call this part v, call this part u, call this part v. Now this function will be changing partially with respect to the other one. Now second derivative is indicated as this with a 2 on top. So we hold u to be a constant, it remains to be ax. Differentiate cos x, it becomes negative sin x, plus remember that each portion changes with respect to the other one. So we are done with u changing with respect to x. Now we go to old v constant cos x with the change occurring on ex only, it will be ex plus. Now we go to the second part. Y can change with respect to v only, so ex remain constant. Change in sin x, it will be cos x plus the second part, old sin x to be constant, differentiate the first part ex, which will be the same as ex. Now let's open the bracket and collect the like terms. This one times this negative ex sin x plus ex cos x plus ex cos x plus ex sin x. Now we are talking about like terms. We realize that this one is the same as this. This one is a negative, this one is a positive. So they cancel out. This one positive, this one positive. They are the same. So we have 2. So we can say that the second derivative of y with respect to x will be dx squared is equals to 2 e raised to x cos x. Double line to indicate that I also need this part to solve my question. Now let's go back to what we were supposed to prove, this part. We are told that prove that when you add dy squared minus 2 dy dx plus 2y, we are supposed to get a 0. We are supposed to get a 0. So let's try and prove that part. The second derivative, this one, so we replace 2ex cos x minus 2 into first derivative, this one, ex cos x plus ex sin x. There. Then the last part plus 2y, it will be plus 2 into y was e raised to x sin x. Open the bracket. 2 e raised to x cos x minus 2 e raised to x cos x minus 2 e raised to x sin x plus 2 e raised to x sin x. Now let's see this. We collect the like terms. This one is the same as this one, positive, negative. They cancel out, so we have a 0. This one are the same, negative, positive. They cancel out, we have a 0. So 0 plus 0 gives us 0. So we can now say that we have proven that adding the second derivative 2 times the first, 2 times the function, we get a 0. So we can now say that therefore the second derivative minus 2 times the first derivative plus 2 times the function is equals to 0. And that is the solution for our question.